Hey and welcome to today's video. Today I'm going to show you how to use the train test split in a Python notebook. So what you're going to learn in this video is that you're going to learn how to use the train test split, and also what the difference between training, test, and validation dataset are, and also the 3 steps to create the datasets in Python. So why do we use train test split? So if you have a task to use machine learning to work on future real-life data. So you have some data and you want to train a machine learning network to work on future data that the model hasn't seen yet. Then you want to use as much as possible of this data while also being able to know how well it will perform in the future when you don't have the data. So the solution is to split the available data into 2 datasets, one for training the model and one for testing it. So in this video, I'm going to use a dataset with 546 rows of housing data, with house prices and listings and areas. So the difference between the sets is really we have the training set, and this is the data we use to train the model. This is usually the majority, 70 to 80%, and that's what we actually use to train the model. The model learns the patterns within this data. We also have a test data set, which is the data that we use to simulate future data that tells us how well the model will perform. So we train, and then we test, and then we evaluate and see how well the model performs. And note that this is only used once after your training is complete. So after you've adjusted your hyperparameters for the training set, it's only then that you try it on the test set. When you try it on the test set, you don't go back and try to make it better, because that's your last prediction of how your model is going to be performing. So the validation dataset, that's optional. That's usually something that comes in tandem with the training set. And that's data that we run our models with while we train to improve our model. So while it doesn't directly influence the training, the model doesn't actually train on the data, you as the user that's actually running the code might tweak your hyperparameters to ensure the highest validation accuracy, because you're optimizing for accuracy on data that the model hasn't seen yet. And the 3 steps to use train test split are: first, to split the data into the 2 pieces, the training and the testing set. Second is to train the model on the training set. And 3, run the model on the testing set and evaluate. So we're gonna do all these 3 steps right now. So the first thing we do is we import the libraries that are crucial for this, and it's pandas and numpy that are the crucial ones, and we're gonna use matplotlib in order to be able to plot the results. So we're gonna import this dataset, and we do that by making a variable called dataframe, and we read it from pd.readcsv. And we have the housing dataset. So it looks like this. We have the price, the area, the bedrooms, bathrooms. It's a normal CSV file downloaded from Kaggle. And in this video, we're going to use the price and the area to make a linear regression model to be able to predict those. So we first import the data, and we have to run everything like this. And let's have a little look at it. So df.head, and we see that we have everything that we need. Now we're going to check the number of the rows in the dataset just to see. It contains 545 rows. And now for the training, we're gonna need to define what features that we want to use. So right now the data frame contains all of these features, and we only want to use the price and the area. So we're going to define the x, the input to the model. That's going to be data frame of the area, because that's what's going into model. We're going to predict the price with the area, and the y then would be data frame of price. And now when we have these features, we're going to split the dataset into the training and testing set. And so this is the most important line of this video. So what we're going to do here is we're going to define 4 variables. We're going to define the x train, which is the x variables of the training dataset. So we have the training, which is 80% normally. We're going to have the x values, so the area, and then we're going to have the y train, which is the actual prices for that dataset. And then we also have x test, which is for the testing that the model is going to use. And we also have the y test, which are the real values that we want to be able to predict. So we're going to split the dataset into training and testing, and the way we do this is we define variables that look like this. First, we get x train, and we also get a variable called xtest. We also now get ytrain and ytest. So that's the order we use, and the reason we use this order is because sklearn has a train test split function that does this work for us. So we're just gonna put in train test split, and the first variable we put in is the first value is the data frame with all of the x values, so all the area, and the second one is the one with all of the y values. And we also use a variable for determining the test size. So right now we're gonna keep 80% for training and 20% for testing. That's what this variable stands for. I'm gonna run this as well. Works well. Now let's have a little look at xtrain to see that everything went well. So we see that it's randomized, and we see that, so the xtrain contains the area. So this is in square feet, I believe. So index 375, this amount of square feet, and it has length 436, which is 80% out of 545. Makes sense. Let's also have a look at the y-test. See that looks good. Yeah, we have the prices in dollars, and the length is the remaining length of the data set. So now that we've divided the data into our training and test, we're gonna train the model on the training set. Sorry. So we're gonna import linear regression, and we're gonna do a little trickery with the data sets just to reshape them. So currently the data was in this shape, which is basically values after each other. And what we want is to have a two-dimensional array with the values right next to each other. So what this means is basically that if we would have liked to add more features in the future, then this would have expanded by 2. So instead of just being a long list of numbers, we actually have a list that goes downwards. So this will be done here. Has no attribute values. Let's run everything again. Yeah, okay, there we go. Now let's create the linear regression model. So the model is equal to linear regression, and then we're gonna fit the model to the training data. So stick with me here. So we've defined the model, and now we're gonna fit the model to the training data. So we write model.fit, and then we input xtrain. So that's the input that it's using, and it's gonna fit the x training data to the y training data. Let's run this, and it took less than a second. Now we're gonna now that the model is trained, it's fit the model to the xtrain variables to the ytrain. Now we're gonna use the model to run on the test set, the data which the model hasn't seen yet. So the way that we do this is we make a new variable called y predictions, or ypred. So that's our guess at what the y-test is gonna be. So that's gonna be model.predict of y-test, x-test, sorry. Because that's what we give the model, and it's gonna predict what the y values actually are. We're gonna run this, great. And in this code right here, after we done our predictions, we're gonna see what the accuracies on the predictions are on the test set compared to the test set. So naturally, we assume that if the model is running on the data that it has already seen, that it will have a higher accuracy than on data that it hasn't seen already. So what we're doing here is we're basically predicting the y-train again, and running some evaluation metrics on it. So if we run it here, we see that on the training set, we get a root mean squared error of $1.4 million. So that means that the average prediction on the test set is $1.4 million off the actual value. The R2 value, which is basically an indicator of how well the model captures the variance in the actual data, we get that it stands for roughly 28% can account for 28% of the variance. On the test set, the data that it hasn't seen, we have a higher error. This is to be expected because the model hasn't seen this data before, hasn't learned from it. Has a root mean squared error of 1.9 millions, which is higher, which is to be expected. The R2 value is also a little bit lower, which does make sense. And now if we're gonna plot this, we're gonna see that here on this graph, the blue data are the training training data and the green are the test data. So the linear regression is basically from the blue points creating this red line that's then used to predict the prices of all the green dots. So the error for the blue dots is lower on average than the error for the green dots when this line is used to predict. So what we're basically saying is that, okay, for this house that has 10,000 square feet, the linear regression model is predicting that the price of this property is going to be $7 million. But in actuality, it was $12 million. So this is quite of a hefty error. So, but on average, the error is roughly $2 million, which does make sense. It's roughly the length of this line. And that's how you use train test split in order to run your data on the training test and then run it on the test set in order to evaluate how well it's going to perform in the future. Thank you very much for watching, and I'll see you in the next video.